pre-calculus honor students. Here are our 3.1 linear inequalities and absolute value. First, a quick refresher on linear inequalities. You solve them just like equations. There's one thing you have to watch out for. This first one, it's pretty straightforward. We subtract 3 from both sides, and so we get 2x is less than 5, and then divide both sides by 2 to get x is less than 5/2. Nothing unusual there. Careful on this one, though. When you subtract 5 from both sides, that preserves the inequality. But when we divide both sides by -1, that inverts the direction of the inequality, so you get x is actually less than -4. So be careful. If A is less than B, then AC is less than BC if C is greater than 0. If C is less than 0, then you will get instead AC is greater than BC, and you'll reverse the direction of inequality. If you multiply or divide by a negative number, it reverses the direction of inequality. And that's just a basic property of our number line. Notice how the positive integers are ordered. If you multiply them by a negative, they are in the reverse order. Okay, just a little mini proof for you there. Multiplying by a negative will invert the order of an inequality. Now, absolute value. Let's start off by getting our definition down for absolute value. The absolute value of x equals plus or minus x. Are we good with that? If I graph that, this is y equals x. This is y equals negative x. So this is wrong. Can't emphasize this enough, that this thinking is wrong, that you just replace the absolute value of x with plus or minus x. I mean, is the absolute value of 3 equal to plus or minus 3? No. So we have to throw out this whole idea and come up with something else. No. The absolute value of x is not equal to plus or minus x. It's not 2x. That wouldn't even be a function. And you know the absolute value function is a function. So let's try that again. Definition of absolute value of x. It's a sophisticated two-part definition. The absolute value of x is equal to two parts. X if x is greater than or equal to 0, or it's equal to the opposite of x if x is less than 0. So it's a piecewise definition. And you can actually enter this in your TI-89 as y1 equals x with x greater than or equal to 0, and enter y2 as the opposite of x with x less than 0. Those big vertical bars are the with symbols, and you can put conditions on it. You can also just enter in y equals ABS of x. That's the TI-89 code for absolute value. And you get a V shape, a domain of all reals. The range, that is what can come out for y, is y greater than or equal to 0. And you get this sharp corner, this vertex at 0, 0. Now let's see how the graph can help us with understanding absolute value inequalities. I'm actually going to start in this first scenario with absolute value of x equals 3. Solve this. Well, from the definition, absolute value of x is equal to itself, or it's equal to the opposite of itself. And then we usually go to -3 then. So x equals 3 or x equals -3. So when it's an absolute value equation, it's not that hard. And we looked at some of those before. And that's where some of the kids get the mistaken impression that they go right from absolute value of x equals 3 to x equals plus or minus 3. And I'll accept that too, because that's basically the same thing as my answer here, like this. X equals plus or minus 3. But then they tend to think that absolute value of x equals plus or minus x. And that's what throws them off on the inequalities. Here we can see that this is why we get our two answers, because that's the intersection of the V with a horizontal line. You'll get two distinct answers, 3 and -3. 3 or -3. Now let's see what happens though when we go absolute value of x is greater than 3. Absolute value of x is greater than 3. Well, that means x is greater than 3, or the opposite of x is greater than 3 from the definition. Thing is, that changes this though when we multiply both sides by negative to x is less than negative 3. And I usually have people just go right to this step, that absolute value or leads to disjoint rays. And we can see why here. Why, or when, is the absolute value graph, that is the blue graph, above the red graph? Well, right in here. We're above here, and we're above over here. So 3 and negative 3 were the intersections. And so we want to represent on the x-axis all these points and all these points to the left of negative 3. That's basically why we come up with these disjoint rays, because the absolute value of v then is going above a horizontal line. You can also look in your reading that they do a geometric definition of this, saying that absolute value of x can also be thought of as the distance from x back to 0. And we're saying the distance from x to 0 is more than 3, so we're more than 3 away from 0. So that means you're going to go to the right of 3 or to the left of negative 3. Now, finally, absolute value of x is less than 3. Well, if we do it strictly by the definition, that means x is less than 3, or the opposite of x is less than 3, x is less than 3, or x is greater than negative 3. Now that seems odd because that means all the points to the left of 3 united with all the points to the right of negative 3, and it looks like you'll get all reals for a solution. But we know that's wrong. So did something go wrong with the definition? No, we just didn't look at the fine print. Look at the fine print. X is less than 3 when x is greater than or equal to 0. That's the condition for ignoring the absolute value, assuming the thing inside is positive. So that actually adds this here. And the absolute value of x equals the opposite of x when x is less than 0. So that means we actually have another condition here that, yeah, it equals the opposite of x though, but x is less than 0, so you get 0 is greater than x is greater than negative 3. Now when you unite those two things, we just get the points from 0 to negative 3 from this, and from over here for the points from 0 to 3. And so it's not all reals, it's negative 3 is less than x is less than 3. So doing it by the definition at this point gets a little messy. You're going to have to go through all those little conditions. So what we do instead, when you see absolute value less than, you think about what you're going to expect. You're going to expect a compact form. And you can see the compact form happening right here. Absolute value is less, x is less than 3. It's when we go below, when the v goes below the horizontal line. And that's going to be all these points represented on the x-axis by everything betwixt negative 3 and 3. So what I want you to do instead, when you see the absolute value of x is less than 3, just put x in between negative 3 and 3, and you're done. Let's practice some more examples. Solve the following inequalities. Absolute value of x plus 8 minus 3 is greater than 0. First, when you're going to decide is it absolute value greater than or absolute value less than, get the absolute value isolated by itself on the left. So we've got absolute value of x plus 8 is greater than 3. So it's absolute value greater than problem. X plus 8 is greater than 3, or x plus 8 is less than a negative 3. So subtract 8, x is greater than negative 5, or x is less than negative 11. Okay, there's your answer. Graphically, it'd be the points to the left of negative 11, or the points to the right of negative 5. Okay, there you go. Now here, solving 3 minus the absolute value of 5x plus 2 is greater than 1. Before you say, oh, that's an absolute value greater than, I know what you're going to have the two cases, the two divergent rays, but look at it for a second here, though. We subtract 3 from both sides, and you get the opposite of the absolute value of 5x plus 2 is greater than negative 2. When you divide by negative, it becomes 5x plus 2 is less than positive 2. So it's an absolute value less than problem. Let's just put the 5x plus 2 in between what two extremes here? Negative 2 to 2. So subtracting 2 from all three parts, negative 4 is less than 5x is less than 0. And then dividing all three parts by 5. Negative 4/5 is less than x is less than 0. Or our solution is basically the set of points, the line segment from negative 4/5 to 0. Like that. Flange out